Welcome back, everyone. Today we're going to be looking at factorizing non-monic quadratics. This one is slightly more challenging, or at least there's an extra kind of step to how we factorize our non-monic quadratics. What that word non-monic means, I know it's a very sort of confusing or complicated word. It just means not the number one, non-monic, mono meaning one, not the number one in front of my x squared term. So anything that's not the number one, like 2, 3, 4, 5, 6, 10, 100, any number in front of my x squared term that isn't one, we call them non-monic, and we have a different technique. Now, I should point out, in order to do this technique, we need to be a little bit familiar with the general form of a quadratic equation. That is ax squared plus bx plus c. Okay, so if I match up my terms, my a term here is going to be 2. My b term is my number in front of my x. Well, that, if there's no number written, I assume there's a number 1. And my c term is going to be negative 15. Now, why that matters is because the technique I like to use when factorizing non-monic quadratics is the a times c method. So I'm going to multiply my a term, that's 2, by my c term, that is negative 15, and that gives negative 30. Now, once I get my new number, I want to do the exact same thing I did in the previous, like the normal monic quadratics, the last video, where I look for numbers that multiply now to give negative 30 instead of negative 15, and add, we still want to add to give 1 or positive 1 here in the middle. So if I do my list of numbers that multiply to give 30, I have 1 and 30, I've got 2 and 15, I've got 5 and 6, I've got 10 and 3, and I think, well, look, we're fine with that number. I think that is the full list. So the same skills we looked at in the last video on how we can deal with this negative sign here is that I'm looking for two numbers that multiply to give a negative. That means I must have one positive and one negative number in my list. Now, because my number here is positive 1, that means the bigger number has to be negative. So make all my big numbers negative here, which means my smaller numbers have to be, all my big numbers positive, which means my smaller numbers have to be negative. Okay, so now if I add all my terms together, I have minus 1 plus 30, that gives 29. I've got negative 2 plus 15, that is going to give 13. I've got negative 5 plus 6, that's going to give 1. And I've got 10 minus 3, that is going to give 7. So once I get my list, I'm looking for essentially numbers that add to give 1. I can see that that is going to be the numbers here in the middle. That is my minus 5 plus 6. So I've identified my pair. Now I need a little bit more room, so I'm going to grab all of this in a little lasso here. I'm going to, actually I'll get the whole thing. I'll get all this in a little circle, and I will shrink this down just slightly. That way I can do the rest of the question. In fact, I might just put my list over here. Seems like a fine place to put that. Instead of putting it in brackets and being done like we do with the monic quadratics, I now rewrite out my expression. So I write out my 2x squared, but I'm going to change my numbers in the middle to the numbers I found over here. So it's going to be 2x squared minus 5x plus 6x, and my minus 15 is going to stay the same. Now, if I look at my equation, I have minus 5 plus 6, that gives 1. I haven't actually changed the question. I've simply just manipulated the mathematics to make it a little bit easier for me to get to my answer. So once I rewrite my quadratic now with 4 terms, I want to use grouping. Now what grouping means is I look at the first 2 terms over here, and I look at my second 2 terms, let's use blue, over here. Okay, so I want to look at for common factors in my yellow terms, common factors in my blue terms, and bring them out the front. If I look for common factors between 2x squared minus 5x, the only common factor I have is simply just the letter x, which means I'm left with 2x minus 5 inside my brackets. If I look for common factors in my second pair, well, they don't have the same letter, so I'm looking for my numbers. I've got the number 6 and the number 15. My common factor there is going to be positive 3, so I'm left with 2x minus 5 again. Now, the reason why I like A times C and why I recommend A times C and why I think even though when we first learn it, it feels like a slower process is because this is a self-checking method. In other words, if I look at inside my brackets, I notice I have the exact same terms in both brackets. If that isn't the case, I've made a mistake and I've got something wrong. So I know every time I do this that my answer that I'm going to get for my factorized quadratic is going to be correct. And once we practice this a little bit, it does get really, really fast. So we can get very quick, it checks itself, and it means I have very high accuracy when I'm answering these questions. So now, what do? Well, my common bracket, the 2x minus 5, I'm going to write here out the front. And my remaining terms, that is my, I'm almost running out of colors here, I'm going to use purple. That is my x and my positive 3. That forms my second bracket, that is x plus 3. Okay, now if I'm not sure, I can expand to check, right? There's a lot of theory for why grouping works. I'm not going to go into it too much here. I want this video to be a little bit shorter. This is how we can factorize any monic quadratic, no matter how hard it is. A times C, factor list, identify your pair, rewrite your quadratic with those two numbers now in the middle, common factor for the first two terms, common factor for the second two terms. You will always get a common bracket if the quadratic is factorizable, and then you have your answer. So hopefully this is helpful. Any questions, feel free to comment those down below. If you have harder versions of this that you're not sure if this method works, you can feel free to comment that. I can make a video showing that it does in fact work for every single factorizable quadratic, and I will see you guys in the next video.